Have you ever wondered how machine learning models actually get built? Well, let me break it down for you. My name is Janelle, and I've been a data scientist for 6 years. I've built quite a few machine learning models. The first step that I take before starting any machine learning task is defining the problem. What business question are we solving? Everything starts here. Are we trying to predict churn? Are we forecasting sales, or are we recommending products? Are we classifying users or grouping behavior? Clear problem statement is going to lead to a successful model. Now, the next step, and probably the longest step of any data science project, cleaning the data. A model-ready data set is so key. You have to think about removing duplicates in your data set. Sometimes you may even need to normalize or scale some numerical features. How are you going to handle missing values? Are you dropping them or imputing them with a mean or a median? Are you going to use another model to impute these values? Then feature engineering. Are there some features that you may need that aren't there yet? We might want to bucket some numerical values. One-hot encoding to turn numerical values into categorical. All of these steps matter more than the model itself. Once the data is clean and we have a model-ready data set, now we can choose the model itself. Depending on the task at hand, we might be using unsupervised learning where we don't have a label, or supervised learning where we do. Within supervised learning, there are other kinds of models. Classification versus regression. Are you trying to predict a continuous outcome? Sales, revenue, wait time. Or are you trying to classify churn versus no churn, fraud versus no fraud? Different algorithms that you can use for classification include XGBoost, logistic regression, neural networks, random forest, SVM. On the unsupervised learning side, maybe you're doing something like clustering, where you want to group similar types of customers. You could also use dimensionality reduction to get highly dimensional data sets to a very small number of dimensions. Some of these could be K-mean or PCA. Finally, we can train and evaluate the model. We split our data into training and test sets, train the model, and evaluate to see how the model performs. Is our model overfitting or underfitting? There are different techniques that we can use to evaluate our model. Accuracy is not a one-size-fits-all. Depending on the problem statement that you determined initially, you may want to consider precision, recall, or F1 score to be a little bit more important. Sometimes the root mean squared error or the mean absolute error could be more important as well. The last step is presenting the results. Models don't speak for themselves. We tell the story. This is the point where you have to really think about presenting technical outcomes to non-technical audiences. What was the business impact of this model? Was there some efficiency gain, some money saved, users reach? Good machine learning isn't just technical. It should drive decisions. Let me know your experience with machine learning. If you have any questions, give me a like or a follow for all things machine learning, data science, data analytics, all things data, and let's talk about it.